These are the guided notes for the radicals and radical operations. Guided notes for Math 026, STEM Track 3. So for the first examples, we're talking about the square roots of numbers. For A, the square root of 81 is 9, because 9 times 9, or 9 squared, gives us 81. For B, because it's a fraction, what we're going to do is we're going to take the square root of the numerator and the square root of the denominator. The square root of 49 is 7, and the square root of 64 is 8. So our answer is 7/8. For C, it's hard because it is a decimal, but if we focus on just the number part of the decimal there, the 16, the square root of 16 I know is 4, because 4 times 4 gives me 16. And then if we remember our rules for multiplying together decimals, you count the number of numbers behind the decimal point. So we would need 4 numbers altogether. So our answer is going to be 400ths. And if I multiply together 400ths twice, it'll give me 16 10,000ths. Now you may notice that D, E, and F are all pretty much the same. It's the square root of 169. It just adds a negative in there in some cases. We are looking for the answers to these, and you'll actually have 3 very different answers. For D, the square root of 169 is simply 13, because 13 times 13 gives me 169. Now for E, this one is a special case, and I want you to pay attention to it. Because we're looking for the square root of 169, and our index, or the number outside the radical, even though we don't see it, is a 2, we can't have a negative under the radical, because a lot of people would say, oh, the answer is negative 13. But if I multiply together negative 13 times negative 13, my answer is going to be a positive 169, not a negative. So for this problem, our answer is not negative 13. It is a non-real answer. So we would just write non-real. Sorry, I'm not good with the pen. Okay. Now, the way to get around that, if you want the negative root of the square root, if you take a look at F, it is acceptable to have the negative on the outside of the radical. It really stands for the opposite of. So the square root of 169 is 13, and if we take the opposite of that, it's going to make it negative. For G, we are going to find the square root of a variable here. So we have x to the 10th power. The way to find the root of a radical with a variable and an exponent, what you're going to do is take the index, and in this case it's 2, so I just wrote it in because we don't see it, and divide it into the exponent. So 10 divided by 2 is 5, so my answer here is going to be x to the 5th power. The way that we can check that is, if you recall, if your rules of exponents, if I take my answer, x to the 5th power, and I square it. Rules of exponents say 1 base, 2 exponents. Remember, this is our power to a power rule. We multiply that, and it will give me 10 to the 5th power. So that's how we check our answer, and that's why we divide. H, we have a number and a variable, so we're going to find first the square root of 121, which is 11. And then when I divide 2 into 14, it's going to give me a to the 7th. So my answer is 11a to the 7th. I, again, same thing. The square root of 400 is 20, and 2 divided by 2 is 1, so we're left over, we have just an r there. So my answer is 20r. Okay, here we're looking for cubed roots. A cubed root is a number that I can multiply together 3 times that will give me the number under the radical. So for the cubed root of 125, my answer is 5. And I can multiply together 5 times 5 times 5. Which gives me 125. So that's how I know that the cubed root of 125 is 5. Now for B, you may look at that and say, well, we can't have a radical underneath or a negative underneath the radical. However, with a cubed root, you can, because I'm going to multiply together the number 3 times. The cubed root of 343 is 7, and because we have a negative here, it's going to be a negative 7. So my answer is negative 7. And the reason we can have a negative when we have an odd index is because if I do negative 7 times negative 7 times negative 7, my answer will give me a negative 343, because 2 negatives make a positive, but that third negative will turn our answer negative. For C, we're looking for the cubed root of that fraction again. So I'm going to do the cubed root of 27, which is 3, over the cubed root of 64, which is 4. So my answer is 3/4. And then D, we have the cubed root of negative 1,000, which is going to be negative 10. But then notice we have another negative on the outside. So here they're saying the opposite of negative 10, which actually is going to lead me to have a positive 10 as an answer, because those 2 negatives make a positive. Okay, E, the cubed root of 8 is 2. And then again, variables, we do the same thing. So we're going to divide 3 into 9. 3 goes into 9 3 times, so I have 2a to the third power for my final answer. For F, the cubed root of 512 is 8. Now, if you're not familiar with a lot of these, I would encourage you to make a list out, like 1 cubed is 1, 2 cubed is 8. So that way you become familiar with them. I would go up for the cubed roots maybe up to like 10 or 11, because those are the ones you'll typically see. And then to finish this problem, 3 goes into 33 11 times. So we're going to have x to the 11th power. Okay, here we're looking at our nth roots. So again, this is where we're going to focus on that index, that number outside the radical, the little number right here. If you have an even index, your number under the radical must be a number greater than 0. Otherwise, it can't. In other words, it can't be a negative number. If you have an odd index, you can have a negative or a positive number under the radical. It doesn't matter. So here, if we take a look at the fourth root of 81, the fourth root of 81 is what number can I multiply together 4 times that will give me 81? And that number happens to be 3. So for A, my answer is 3. Now B, they have a negative under the radical, and it's an even index. So in that case, we cannot have that negative there. Our answer is just simply a non-real number. So that's what you would state for your answer. C, they don't have the negative under the radical. It is outside the radical, so they're really asking for the opposite of the fourth root of 81. We know that the fourth root of 81 is 3, and then when they ask for the opposite of that negative, it makes it a negative 3. D, this time we're looking for the fifth root of 32. It's an odd index, so we can have a positive or a negative number underneath that radical and still find the answer. The fifth root of 32, the number that I can multiply together 5 times, is 2. So D, the answer is 2. E, because it's a negative 32 under the radical, my answer is negative 2. And then F, here, they want the fifth root of 32 and then the opposite. The fifth root of 32 is 2, and then that negative on the outside will also make that answer a negative as well. Okay, here is the section on approximating roots. And the directions ask us to approximate the following roots, first by hand and then by using a calculator. When they ask you to approximate it by hand, they really want you to kind of estimate what the answer is. Now, all three of our problems are not perfect squares. So I know my answer is not going to be a perfect whole number because it's not a perfect square. But the square root of 107, I do know that the answer is going to be between 10 and 11. I know this because 10 squared is 100. So the square root of 100 is 10. And 11 squared is 121. So the square root of 121 is 11. If you notice, 107, that number falls directly between 100 and 121. So my answer is going to be between 10 and 11. It will start with a 10, and it'll be a decimal. Now, 107 is closer to 100, so I'm going to say, it's going to be closer to 10 than it is to 11. When I use a calculator to estimate it, I get 10.34, 10 and 34 hundredths. There's more numbers after the decimal, but I'm kind of rounding it. So my answer is going to be 10 and 34 hundredths. So I did round my answer. Perfect or numbers that are not perfect squares are irrational numbers, which means that they continue on infinitely and do not repeat without a pattern. So again, we have to round it to approximate our answer. We can't get an exact answer. Next, we're looking for the cubed root of 176. And the cubed root means we have to find that number that we can multiply together 3 times to get 176. Now, again, I can find out what 2 numbers it's between by looking at my perfect cubes. And I know that, again, 5 cubed, get on there. Sorry, it's not writing. There we go. 5 cubed equals 125. And 6 cubed is equal to 216. 176 falls between those 2 numbers. So my answer is going to be between 5 and 6. It'll be, I'm going to say 176. It's kind of pretty close to the middle there. It's maybe a little bit closer to 216. So when I do the math on the calculator and find the cubed root of 176, my final answer, if I round it to the hundredth, is 5 and 60 hundredths, or, because I don't really need that 0, 5 and 6 tenths. All right, C. We're finding the square root here. We're finding the square root of a fraction. If you recall, a fraction is part of a whole, and all fractions, as long as they're proper fractions, are between 0 and 1. So I know here that my answer is going to be less than 1, because this 2/17 is less than 1 decimally. If I evaluate it on my calculator and I find the square root of 2/17, I get an answer of 34 hundredths when I round to the hundredths. Okay, here we are looking at rational exponents. A rational exponent is an exponent that is a fraction. For example, like if you look at your notes, you have 7 2/3. This is a rational exponent. You can take any rational exponent and write it as a radical expression. Here, we're going to take a look at 9 1/2. Anytime you take a number written in power form and write it as a radical, what you're going to do is the base of the exponent, the 9, is the number under the radical. Then your fraction, your denominator is always your index. So our denominator here is a 2. I wrote the 2 in, but because it's the square root, we don't have to put it in there. And then the numerator is the exponent. You can either put it with the base, or sometimes people write it, they put parentheses and they write it on the outside. You can do it either way. It's up to you what makes it easier. And then from there, we can evaluate. So I know that the square root of 9 is equal to 3. So that's my final answer. Now, for B, we have 125 to the 1/3 power. So again, when I write it in radical form, my number under the radical is my 125. And then my power of the 125 is the numerator, which is a 1. And the index is a 3. So we're looking for the cubed root of 125 here, which if we recall from before is 5. Okay, for C, this time we have a negative exponent. And recall in math, we don't like negative exponents. So if it's negative, we want to get rid of the negative exponent by, if you recall, taking the reciprocal. So we're really going to write this as 1 over 81 to the 1/4 power. When I flip it, it makes it positive. And then we're going to turn it into a radical so that we can evaluate it. So now I have 1 over, and again, our index is 81. Our exponent is a 1, which we don't have to put in there. I'm just putting it in there to show you. And our index for our radical is 4. And the 4th root of 81, again, if you recall from before, is 3. So my final answer here is 1/3. Now the bottom 3 examples, we do a little bit more work with them here because we have an exponent of a number greater than 1. So we have to evaluate that as well. Here, I'm going to take 25 to the 3/2 power and write it in power or radical form first. So here I am going to have the square root of 25, and then I'm going to put it this way. I'm going to put parentheses raised to the 3rd power. You can do it either way. I think this is a little bit easier, but it's up to you. The square root of 25 is 5, and then we have to evaluate our exponent. So kind of think of order of operations, parentheses, then exponents. And 5 cubed is 125, so that's our final answer. Now for E, we have negative 64 to the 2/3 power. Again, I'm going to put it under the radical. So here's my radical. I have my negative 64. Because my denominator is a 3, that's my index. And then my exponent is going to be a 2. The cubed root of negative 64 is a negative 4. And then we're going to square that. And 4 times 4, or negative 4 times negative 4 is 16. So that's my final answer. Now for F, again, we have a negative fraction, negative exponent, so we have to flip it. But when we flip it, our base, the negative 32, does not become a positive. It's just the exponent. So I'm really going to start off with 1 over negative 32 to the 4/5 power. And when we evaluate that, we'll have 1 over, we'll put our radical, our negative 32 goes on the inside. The index is 5, because that's my denominator. And my exponent is going to be 4. The 5th root of negative 32 is negative 2. And then what we're going to do is raise that to the 4th power. So my final answer is going to be 1 over positive 16, because negative 2 times negative 2 times negative 2 times negative 2 will give me a positive 16. Okay, here we are approximating the following powers to the nearest thousandths using a calculator. So what we're going to do is I typed into my calculator 1000 raised to the 5/7 power, and I use a TI 84 graphing calculator. So remember, when you put the exponent in, because it is a fraction, you want to put parentheses around that fraction. And I typed it in and I got 138 and then 0.9495494. However, again, they want us to round to the nearest thousandths, and because it's not a perfect square or a perfect, in this case, 7th root, it's going to go on infinitely without repeating in a pattern. So you want to expect a long decimal number. We're going to round to the thousandths, which is the 3rd decimal place. Because my answer, here's what I have. I have 138.9495, and I want to round to the thousandths. But because my number here is a 5, I have to round up. That's going to automatically turn my 9 into a 10. So my final answer is going to be 138.95, because that decimal, when I rounded up, the 9 became a 10. Now for B, again, I typed into my calculator. Notice here, number-wise, we have a negative exponent. So that means we're going to flip our problem. It's actually going to be a fraction. So your answer here should be less than 1. And I get decimal points 0.0378. I'm going to go out 4 places so I can show you my rounding. Again, I'm going to round to the thousandths place, which is the 7. Because my number next door is an 8, that means that the 7 will round up. So my answer is 38 thousandths. For C, when I entered into a calculator, my answer is negative decimal point 8, erase that, 84. Erase for you, okay. So it's 8, 4, 6, 9. And again, I'm rounding to the thousandths. That's a 9, so my 6 will become a 7. So my answer is negative 847 thousandths. Okay, here we are looking at expressions, and they ask us to simplify them and write the answer as a radical. Well, here we have x to the 2/3 power times x to the 1/5 power. And if you recall, when we're multiplying powers, we multiply, we add our exponents when we multiply powers with like bases. So what I'm going to do to start to simplify this is I am going to start by adding my exponents. So I'm going to add 2/3 plus 1/5. Now, if you remember, when we add fractions, we have to have a common denominator. So my common denominator that I'm going to use is going to be 15. So for 2/3, if I make it have a denominator of 15, 3 times 5 gives me 15. So I have to multiply the 2 times 5 as well, which gives me a 10. And then on the second fraction, if I use a denominator of 15, 5 times 3 will give me 15. So 1 times 3 is 3. So when I add my exponents here, I'm left with x to the 13/15th power. Now, the final thing that they want you to do is to write it as a radical. So my final answer, remember your x is going to be the radicand under the radical. 15 will be my index, and 13 is my power. And again, you can put parentheses in and write it, or you can put it right next to the x. And that's our final answer. We really can't do anything with it. We can't simplify it, so that's our answer. For B, they're in radical form, but they want us to simplify it. So what we need to do first to make it easier, we can't divide them because my indexes are not the same, so we can't do any division here. But I can write them in fraction form or power form with the fraction for the exponent, and then solve it from there and go from there. So I'm going to take my numerator and convert it into fraction form. So it's going to be a to the 6/5 power. And we also have my bottom part will be a to the 1/2 power. Because again, if you don't see it, the index is 2, and there's no exponent that we see, so it's always a 1. Now recall, when we divide powers, we subtract our exponents. So really, to solve this, I'm going to do a, and I'm going to take my 6/5 minus 1/2. Again, I need a common denominator. So my denominator is going to be 10 here. So I will have a, and it will be, I can do 5 times 2 to get 10. So 6 times 2 is 12. Minus, and then 2 times 5 is 10. So 1 times 5 is 5. And when we subtract, we get a to the 7/10 power. And then again, the last thing to do is to write it as a radical, because that's what they want. So here's my radical. A goes underneath. 10 is my index, and my power is 7. And again, we can put it underneath with the a, or we can put parentheses in it outside. So I'm going to show it to you 2 different ways. I did it the other way up top, so I'll do it this way here. Okay, now for C, it's our final one, and it's going to require a little bit more work. Let me see if I can. Okay, so to take a look at C. First, I'm going to convert it all to fraction form. So I'm going to have, we will have C to the 1/4 power times C to the negative 1/2 over C to the 2/3 power. So to solve this, I think, let's see here, I'm going to start by simplifying the top first. I'm going to add my exponents up there because it is multiplication. And I'm going to use a common denominator of 4. So we're going to have C, and we're going to have 1/4 plus negative 2/4. Because again, I made it have a common denominator. And that's still over my C to the 2/3. I haven't gotten rid of it. I'm just not using it yet. Okay, when I add, I'm going to get C to the negative 1/4 power on the top. And again, I still have my C to the 2/3 power on the bottom. Now, here we have division with powers. So again, we're going to subtract our powers. So I'm going to do C, and I'm going to use 12 as my common denominator. So I'm going to have negative 3/12, because 4 times 3 is 12, so I'll do 1 times 3. I have negative 3/12 minus, and then 2/3 would become 12 there, and 8, because 3 times 4 is 12, 2 times 4 is 8. So negative 3/12 minus 8/12. Again, we can do our addition of the opposite for our rules of integers. So my answer is going to be negative 11/12. And here, because we have a negative exponent, we want to make it positive. So we are going to flip it. We're going to have it be 1 over c to the 11/12. And then the last thing we need to do is put it into radical form. So it's going to become 1 over and then we'll have our radical here. C, my index is 12, and my power is 11. Okay, here we are multiplying or dividing using the product or the quotient rule. And the product rule of radicals states that when you multiply, you must have the same index. So our number outside that radical, I can't multiply together a square root and a cubed root. I have to use 2 cubed roots or 2 square roots. Otherwise, if my indexes are different, like we just saw in the past section, I turn them into rational exponents and then simplify that way. But here, my index is the same, so I can go ahead and multiply it. Really, what it's doing is I'm going to take, because they're both the cubed root, I can combine them under one radical. And that is 8 times right there. And multiply together. So if I multiply 6 times 3, I get 18. And x times x is 18, or x squared, so we have 18 x squared. And then if you can, you do any simplifying, but I can't do any here, so we're done. For b, I'm going to multiply 18 times 2. They're both square roots, so I can multiply them together. 18 times 2 is 36. So now I have the square root of 36, which I know is a perfect square, and my final answer is 6. Okay, for C, we are looking for to multiply the 4th root of 27, a to the 3rd, b to the 8th, times the 4th root of 3, ab. So I'm going to again combine it under one radical. And I'm going to use my commutative property here, and I'm going to put the like terms together. So I put the numbers together, a to the 3rd, and a together, b to the 8th, and b. 27 times 3 is 81. So I'm going to have an 81 here. Again, I got to keep my radical, my index of 4. A cubed times a. Remember, add those exponents when you multiply with like bases, so I get a to the 4th. And b to the 8th times b will give me b to the 9th. Now, if you look at this one, we can do some simplifying here. The 4th root of 81 is 3. A to the 4th. 4 divided into 4 goes 1 whole time. So I have a 3a. And then 4 divides into 9 twice. So I have b squared, but I do have a remainder. I have one of those b's left over. So I'm going to leave that under the radical. So I'll have 3ab squared, 4th root of b. And that's my final answer. Okay, here We are dividing radicals with the same index. And again, to divide or multiply radicals, you have to have the same index. For D, it's written as two separate radicals, but I can't find the square root of 125. It's not a perfect square, nor is the square root of 5, or x squared, or x cubed, or x. So what I'm going to do is I can write it as two separate radicals, or I can write it as one large radical. So I'm going to write it as one large radical. So I'm going to have okay. And what I'm going to do is simplify under the radical first. I'm going to actually, now that it's written as one large radical and I have a fraction under there, I know that 5 goes into 125 25 times. And x cubed divided by x, again, you subtract your exponents, so you get x squared. And it's still under the radical. But if we look now, that's much easier to simplify because the square root of 25 is 5. The square root of x squared is x. So my final answer is 5x. Okay, for C, again, I'm going to do the same thing. I'm going to combine it and make it into one large radical instead of two separate ones. So I'm going to have 56 p to the 19th q to the 25th over 7 p to the 4th q to the 7th. And when I go to simplify that, 7 into 56 goes 8 times. P to the 19th divided by p to the 4th, again, subtract those exponents, you get p to the 15th power. Q to the 15th divided by q to the 7th will give me q to, oh, excuse me, that's the 25th power. And then to the 7th, so you subtract and you get q to the 18th power. Okay, again, we can simplify this. The cubed root of 8 is 2. 3 goes into 15 5 times, so we have 2p to the 5th. And 3 goes into 18 6 times, so q to the 6th. And that's our final answer, 2p to the 5th, q to the 6th. Now F, if you look at it, it is already written as one large fraction. However, I can't take the fourth root of 16 over 81, but if I split it up, I can take the fourth root of each. So if I write it like this, then I can simplify it. The fourth root of 16 is 2, and the fourth root of 81 is 3. So our answer is 2/3. Okay, here, again, we are simplifying this time, again, because we have one single fraction where I can't take the cubed root of all of it, I am going to separate it. So I'm going to start off with the cubed root I'm going to start off with the cubed root of negative 126 over the cubed root of 125. Now, here is a case where the cubed root of negative 126, I don't know the answer to it. It is not a perfect cube, but I know that the cubed root of 125 is 5. So I can simplify it as much as possible. What I'm going to do is leave my numerator alone, but take the cubed root of 125, which is 5, and that's my simplified answer. I can't do any more. Now for H, we have that negative on the outside, so I'm just going to put my negative, move it to the numerator, and I have the fifth root of x squared on the top over the fifth root of 32y to the 10th. On the top, again, there's nothing that I can do. 5 does not go into 2, so I'm going to leave it as a negative fifth root of x squared. But on the bottom, the fifth root of 32 is equal to 2, and 5 divides into 10 2 times, so I have 2y squared. And that's my final answer. I can't do any more, so that's the answer for that one. And then our last one, again, I'm going to divide it up and make it the square root of 64a to the 9th over the square root of 81b to the 10th. And the square root of 64, we know, is 8. I also know that 2 goes into 9 4 times, so I'm going to have a to the 4th. But I still have one a left over, so I'm going to have the square root of a here. Can't do any more with that. On the bottom, the square root of 81 is 9. 2 goes into 10 5 times, so we have b to the 5th power. And that's my final answer there. Okay, here we are simplifying radicals. And this is a very useful skill. I kind of think of it, it's almost like simplifying fractions because we're pulling out, basically when we simplify a radical, you're pulling out either the perfect square or the perfect cube or the perfect root that is in that problem. So the square root of 12, it's not a perfect square, but there is a factor of 12 that is a perfect square. So I can simplify it without having to turn it into a decimal, because remember, our numbers that aren't perfect squares are going to be decimals that never end and never repeat in a number or in a pattern because they're irrational. I can leave it in radical form, but put it in simplest form. So what you need to do is look at your factors of 12. And if I write over here 12, I know to get 12, I can do 1 times 12, 2 times 6, and 3 times 4. And what I'm looking for are factors that have a perfect square in them. Remember, our perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Within that list that I just gave you, 4 is a perfect square. So instead of writing the square root of 12 as the square root of 12, I'm going to break it down. I'm going to say it's really the square root of 4 times the square root of 3. And we know that the square root of 4 is 2, and the square root of 3 I can't do anything with. So I'm going to leave it under the radical. So this is my simplified answer, 2 square root 3. Okay. 72. I know that I can multiply together 36 times 2 to get 72. And 36 is a perfect square. So my answer will be 6 square root 2. This is where knowing those math facts really helps out, and it helps you find the number or the perfect square. And again, if you make a list of those perfect squares, right over here, if I just list them out, 1 squared equals 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Okay, it's a good list to have. Write it out on a paper somewhere. Also, your perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. So again, have that list handy to help you. And that list right there will help us with C. We're looking for the cubed root of 72. So here, I don't want to find perfect squares that are factors of 72, but perfect cubes. And I do know, I'm going to put it up here so we have space, that I can do 8 times 9. And the cubed root of 8 is 2. So my answer will be 2 cubed root of 9. And then I can't do any more. Okay. For D, we need perfect fourths. And this one's tough, but I do know that 16 times 4 will give me 64. The fourth root of 16 is 2. So 2 times the fourth root of 4 is my final answer. Now, when you have variables, we've actually practiced this a little bit already. It's pretty easy because, again, you're just going to take the index and divide it into your number. Really, whatever's your remainder in your division problem stays under the radical. The whole number comes out. So 2 goes into 7 3 times. So I'm going to have x cubed on the outside. And I know that I'm going to have 1 x left over because 2 times 3 is 6. I need to get to 7. I have 1 left over. Now, y, 2 goes into 12 6 times, so it's an even number. I don't have any leftovers, so I'll have y to the 6th on the outside times the square root of x, and that's my final answer. For f, we have to break down not only variables, but numbers as well. The square root of 48. Let's see, to get 48, I can do 4 times 12, which 4 is a perfect square. But then 12, which we saw above, we can break it down further. So there's a bigger square root that goes into it, and that happens to be 16. So the square root of 16 times the square root of 3 is how I break down 48. So it's going to become 4. Now I have a square root of 3 over here. But I also have to look at the variables. 2 goes into 16 8 times, so I'll have a to the 8th on the outside. And also, 2 goes into 10 5 times, so b to the 5th. So my answer is 4, a to the 8th, b to the 5th, square root 3. All right, now for G, we're going to break down the square root of 500. And then we have f, g to the 2nd, h to the 3rd. For 500, I'm going to use 100 times 5. Okay. The square root of 100 is 10. The square root of 5 I can't do anything with, so I'll leave it there. Okay. Then when I look at my variables, f is all by itself. 2 does not go into 1, so I'm going to put, at least not with a whole number answer, so I'm going to put f underneath there, keep it under there. 2 divides into 2 for g squared once, so I'll have 1 g outside. And then 2 goes into 3 one time, so I'll have an h. And there's a remainder of 1, so I'll have 1h underneath the radical. Okay, here, again, we're looking at simplifying. We have some cubed roots here. For 16, again, I know that the cubed root of 8 is 2, and 8 times 2 gives me 16. So I can simplify that somewhat, and I will get the cubed root, or excuse me, let me erase that part. Oops, sorry, wrong thing. There we go. Let's erase this. All right, so we're going to do the cubed root of 8 times the cubed root of 2. And the cubed root of 8 is 2. And then I'm going to leave it over here. I'm still going to have my cubed root of 2. Then I have to look at my variables. 3 divides into 9 evenly 3 times, so I'll have x to the 3rd power outside. And then 3 divides into 14 4 times, so I'll have y to the 4th on the outside. And I have 2 left over, a remainder of 2 when I divide, so I'll have y to the 2nd on the inside. So that's my final answer. It is 2x cubed y to the 4th times the cubed root of 2y squared. All right, for I, we are looking for the cubed root of 128, a to the 22nd, b to the 23rd. I know that 64 times 2 will give me 128. And the cubed root of 64 happens to be 4. So we're going to break it down. So the cubed root of 64 is 4. And then we have our cubed root of 2 here left over. Now, 3 divides into 22 7 times. So we'll have a to the 7th out here. And we have a remainder of 1. So I'll put my 2 there and my a that's left over there. 3 also divides into 23, again, 7 times. So I'll have b to the 7th on the outside. But this time I have a remainder of 2. So I'll put that on the inside. So my final answer is 4, a to the 7th, b to the 7th, and then the cubed root of 2ab squared. All right, for J, we are going to draw a line down here just so I can have space. Okay. Now we're looking at the 4th root of 162, s to the 20th, t to the 30th. Not a perfect 4th root, but we can simplify it. 81 times 2 will also give me 162. And I know that the 4th root of 81 is 3. And then we'll just keep our 4th root of 2 there. We can't do anything with it. So the 4th root of 81 is 3. And then over here, we still have our 4th root of 2, and we'll keep going. Let's see, we have s to the 20th. 4 divides into 20 5 times. So we'll have s to the 5th. And 4 goes into 30 7 times. So we'll have t to the 7th. But we will have a remainder of 2. So we'll have t to the 2nd there. So I have 3 s to the 5th, t to the 7th, and then the 4th root of 2t squared. And that's our final answer. Okay, here we are adding or subtracting radicals. This is part of our radical operations. In order to add or subtract radicals, you must have like radicals. So like radicals means that within or underneath that radical symbol, you have the same radicand, and they also have to have the same index. It's almost like, I think it actually is, the same as combining like terms, where we can add 3x plus 5x together, but if I wanted to add 3x squared plus 5x, they're not like terms, so I can't combine them. So here, if we look at this problem that we have, I have 3 to the square root, 3 square root 7. And I have negative 2 square root 5, negative 12 square root 5, and then I also have negative 10 square root 7. So when we subtract these two or combine here, I'm going to add like radicals. So 3 square root 7 minus 10 square root 7 is going to combine to be negative 7 square root 7. All I did was take the number on the outside, the coefficient, and add that together, kept the radicand the same, or the radical. And then next, what I'm going to do is look at my radicals with the 5 as the radicand. I have negative 2 square root 5 minus 12 square root 5, which is going to give me a negative 14 square root 5. And that is our final answer there, because I can't do anything. I have the square root of 7, I have the square root of 5, so there's nothing that I can do to combine them. if you take a look at B, when I go to add these together, I have the cubed root of 2, and I have the square root of 2. It looks like, if you look at it really quickly, that, oh, I can combine these because they both have a 2 in the radical, under the radical. The radicand is 2. But our index is different. I have a 3 and I have a 2 as the square root of 2. I cannot combine them. It's like trying to combine x squared and x. It's not allowed. So I can't add those together. And then I have the cubed root of 5 and the square root of 7. So this expression, because there's nothing that has a like radical, it can't be combined. So it is considered already simplified. Okay, here we are going to continue to add. But if you notice, if I look at the first problem, I don't have any like radicals right now. However, I do know that the square root of 8, it's not in simplest form. I can simplify that. There's a perfect square that is a factor of 8 that I can pull out of that radical. So remember, the square root of 8 is the same as doing the square root of 4 times the square root of 2. So if I simplify the square root of 8, this is what I'm looking at, just the square root of 8 right now, it becomes 2 square root of 2. Now, I'm going to add that to my 2 that's already there, my coefficient. So really what I have is 2 times 2 square root of 2, because that 2 came from my coefficient. 2 times 2 is 4. So right now I have 4 square root 2. And then here my 3 times the square root of 32. 32, if you recall, can be simplified multiplying together 16 times 2. So what I'm going to do is I'm going to keep my 3 there. I'm going to put it with my square root of 16 and then times my square root of 2. The square root of 16 is 4, so we're going to end up with 3 times 4 times the square root of 2. 3 times 4 is 12. And then we have our square root 2. Okay. 4 plus 12 is 16. And then we keep our square root of 2, because now we have the like radical. So we can add it together. All right, B. This time we have 3 radicals that we have to see if we can simplify. Here, the square root of 125, not a perfect square. But we did this earlier. I know that I can do 25 times 5. And let me... So we have the square root of 5 and the square root of 25, which becomes 5 square root 5 minus square root of 20. If you recall, we have our 3 here. We can do the square root of 4 times the square root of 5. Square root of 4 is 2. So we're going to end up with 6 square root 5. And then our last one is going to be 4 times the square root of 9 times the square root of 5. Square root of 9 is 3. So we have 4 times 3 and then the square root of 5. Okay, we have our square root of 5 here. So we're going to have 4 times 3 is 12. And we'll have square root of 5. Okay. Now, if you notice, all of our radicals are the same. So I can go ahead and do the subtraction. 5 minus 6 is negative 1. Negative 1 minus 12 will give me a negative 13 square root 5. And that's my final answer. All right, so here we need to simplify our radicals before we can add or subtract like radicals. The square root of 54 can be broken down. We have our 4, and I can do 9 times 6. So I'm going to make it the square root of 9 times the square root of 6. The square root of 9 is 3, so I'm going to end up with 4 times 3, square root 6. 4 times 3 is 12, so I'll have 12 square root 6 for the first one. Then 7 square root 6, that's already simplified. I can't do anything with it. So I have 12 square root 6 minus 7 square root 6. And then 8 square root 96. 96 is the same as 16 times 6. So I can break it down to 8 square root 16 times the square root of 6. The square root of 16 is 4. 8 times 4 will give me 32. And we have the square root of 6. So we have 32 square root 6. So it's plus 32 square root 6. If I do my math, 12 minus 7, combining coefficients, will give me 5. 5 plus 32 will give me 37 square root 6. Okay, for D, now we're not dealing with square roots, we're dealing with cubed roots. And here, the first one, it's actually a perfect cube, so I can solve it. I can turn it into the whole number 2. Now, for the second one, it's 4 times the cubed root of 54. I know that for 54, we can multiply together 54, let's see, to get 54, it's 27 times 2, which 27 is a perfect cube. So I'm going to simplify it up here. It would be 4 times the cubed root of 27 times the cubed root of 2. 27, the cubed root of 27 is 3. 4 times 3 is 12, so we have 12 cubed root of 2. And then we already have our 6. The cubed root of 2 is simplified, so it's 6 cubed root of 2. And now if we notice, this 2, it's just like a constant term. I can't do anything with it, but I can leave it here. And then I can combine the second 2 because they both have a cubed root of 2 as their like term. 12 plus 6 will give me 18, so I have 18 cubed root of 2. And I'm done because I can't do any more. They're not like terms. I can't add them any further. Okay, here are our last 2 addition and subtraction examples, and then we'll look at multiplying radicals. For E, 5x times the square root of x is simplified. There's simply nothing that I can simplify or do to that radical, so I'm going to leave it as is. But if you look at the second one, it's 6 times the square root of 4x cubed. I can simplify that. The square root of 4 is 2, so that pulls that out, and 2 divides into 3 one time. So really, I'm going to have 6 times 2x and 1x left over. So when I simplify that, I'm going to have 5x times the square root of x plus 6 times 2 is 12. And we have our x there, and then we also have our square root of x. So now that I've simplified the second term, I can go ahead and add these together because they both have the square root of x as their radical. 5x plus 12x, they have to be common terms. 5x plus 12x are like terms. I can add them together. It gives me 17x square root of x as my final answer. Okay, F. Again, we want to simplify our radicals as much as we can. My first one, we have 2x and then 3x cubed. I can pull out 1x from there because 2 divides into 3 one whole time with an extra left over. So what I'm going to do is I'll write it off to the side here. My 3x cubed will become x times the radical of 3x when you simplify it. So I'm going to multiply that times my 2x. And that's going to give me 2x squared times the radical of 3x. Let's see, for the next problem, we have 5x squared times the radical of 27x. Here, 27 is not a perfect square. I only have one x underneath, but 27, I can do 9 times 3. So we have our 5x squared, and then I'm going to do times the square root of 9 and times 3x. When we simplify that, the square root of 9 is 3, so it'll really be 5x squared times 3 times the square root of 3x. And it's going to give me 15x squared square root of 3x. Okay. For f, let's see here. We have the square root of 12x to the 5th. I know that 4 times 3, again, will give me 12. So if I break it down, I'm going to keep my 8. I'll do the square root of 4 times the square root of 3. And my x to the 5th. 2 goes into 5, 2 whole times with 1 left over. So what I'm going to do is I'm going to put x to the 5th there, and I'll break it down in a minute. Square root of 4 is 2. 8 times 2 is 16. And don't forget, we have x to the 5th here. It goes in 2 times, so we have x squared with 1x left over. So we're going to have a 3 and an x left over. So it's going to be plus 16x squared times the square root of 3x. Put it on. Okay. Now, all of our radicals are 3x with the same index of 2. And all of our terms are x squared terms, so we can add them together. 2x squared minus 15x squared is 13x squared. 13x squared plus 16x squared is going to give me, for my, negative 13, or excuse me, 2x squared minus 15x squared is negative 13x squared square root 3x plus 16x squared square root 3x. So our final answer is going to be 3x squared square root of 3x. Okay, here we are multiplying radicals. And again, to multiply radicals, you have to have the same index, but the number underneath the radical, the radicand, does not have to be the same. So what we're going to do here is we're going to use our distributive property and multiply 2 square root 3 times our 2 terms on the inside. What you're going to do is multiply your coefficients, or your number outside, and get that answer. So 2 times 3 is 6, and then multiply the numbers underneath the radical, and 3 times 27 is 81. So we'll have 6 square root 81, so they stay under the radical. Keep our minus sign, And then we'll do 2 times 4 square root 7. 2 times 4 is 8. And 3 times 7 is 21. So we'll have the square root of 21. And then you want to simplify if you can. In this case, I know that the square root of 81 is 9, and 6 times 9 will give me 54. So what I did is I took the square root of 81, multiplied it times my 6. So 6 times 9 gives me 54. And square root of 21 can't be broken down. The only factors are 3 and 7, and they're not perfect squares. So it's just our answer is going to be 54 minus 8 square root 21. That's your final answer. Okay, for B, again, we're going to do the same thing. We are going to distribute and then simplify if possible. So, just so you know, remember, if you don't see a coefficient outside that radical, it's always, I call it the imaginary one or invisible one. There's a 1 there. So if you need it, it helps you to write it in. You can. So here we have the square root of 6x times the square root of x, which is going to give me the square root of 6x squared. Okay. Then we'll keep our plus sign. Again, 1 times 2 is 2, so the outside number will stay the same. And then the square root of 6x times 2 will give us the square root of 12x. Keep our minus sign. 1 times 5 is 5. And then the square root of 6x times the square root of 6x will give us 36x squared. Now I need to simplify if I can. The square root of 6x squared, can't do anything with it, so we're going to leave it as is. Okay. Now here, remember, R12, we can simplify that and make it into 4 times 3. So we're going to have 2, I'm going to simplify it up here, times the square root of 4 times the square root of 3, I'll keep the x there. The square root of 4 is 2, so we'll have 2 times 2 times the square root of 3x, which is going to give us 4 square root 3x. This is good, but I really can't simplify anything yet. I could have to leave it like this. They're not like terms, but it's simplified. And then over here, the square root of 36x squared is going to be 6x. So we're going to have 5 times 6x, which will give us 30x. And that's our final answer. We can't do anything else to it. There's no like radicals, so we can't add anything together. So that's our final answer. Okay, here we are going to multiply. When we multiply here, because we have a binomial times a binomial, this is where, if you guys recall, we are going to use FOIL to multiply, which stands for first, outer, inner, and last. So I'm going to start, multiply my first terms together. 2 times 4 gives me 8. Square root of x times the square root of x gives me the square root of x squared. Okay. Then we're going to do our outer terms. So the 2 square root of x times negative 7 square root y. 2 times negative 7 gives me a negative 14, and we'll have a square root of xy. Next, it is our inner terms, so the 2 inner terms. 5 times 4 is 20. That's positive. And we'll still have our square root xy. And let me get rid of this line. It'll erase for me. I don't know why it won't erase. All right, well, it won't erase. That's okay. Well, I'll just add it down here and I'll simplify it. Now, our last, or L, is our last terms. Go up here, and it's the 5y, square root y, minus 7 square root y, which is going to give me negative 35 square root y squared. When I go to simplify this, if you notice, the square root of x squared is x, so that can simplify to 8x. My middle two terms, I have negative 14 square root xy and positive 20 square root xy. If I combine negative 14 plus 20, I will get a positive 6, and I'll keep my square root xy. And then I have a negative 35 times the square root of y squared, which will simplify to 35y. And that's my final answer. We're going to do the same thing over here with d. And we're going to multiply our first terms first. 5 times 5 is 25. And the square root of 3 times the square root of 3 is 9. Now, you may recognize we can simplify that. The square root of 9 is 3, so we can do 25 times 3, and I get 75. And we're going to do our outer terms. Okay. Square root 5 square root 3 times 2 square root 7 is going to give me, it's going to be positive 10 square root 21. Okay, I can't do anything with that, so I'm going to put it down here. My inner terms are going to be negative 2 square root 7 and 5 square root 3. So it's going to end up being negative 10 square root 21. And then my last terms, negative 2 times positive 2 will give me a negative 4. And it'll be, actually I'm going to put that, let me erase that. I'm going to put it up top here. So it'll be negative 4, and 7 times 7 is 49, square root of 49. We know the square root of 49 is 7, so negative 4 times 7 will give me a negative 28. And then if you look, when we combine our middle two terms, they have the like radical. Positive 10 minus 10 gives me 0, or 0 times the square root of 21. So what happens is those middle terms equal 0. They cancel each other out. So right now I'm left with 75 minus 28, which are two whole numbers. We can do the math, and we get 47. All right, here are our last two problems for this set of notes. And again, they're multiplying, and we're going to use FOIL to help us multiply. Here, we have 3 plus 2 times the square root of a squared. And you have to be careful with this. You can't just square the 3 and square the 2 square root of a and get your answer. You're squaring the entire expression. So when you write out your problem, you're going to have 3 plus 2 square root of a times 3 plus 2 square root of a. And we'll do FOIL. For our first terms, 3 times 3 is 9. Outer will give me 3 times 2 is 6, so we'll have 6 square root a. Inner will also give me 6 square root a. And then my last terms will give me 4 times the square root of a squared. When I go to simplify this, I can leave my 9. 6 plus 6, and they're like radicals, so it will give me plus 12 square root a plus 4, and then the square root of a squared is a, so it'll be 4a. Now I have 3 terms down here, but I can't simplify any further, so that's my final answer. We have 9 plus 12 square root a plus 4a. All right, and F, our last example, same thing. First thing you're going to do is write out the expression 2 times. All right, and we are going to start off. First, we're going to multiply 5 times the square root of x times 5 square root of x. So we get 25 times the square root of x squared. minus, when we do our outers, it's going to give us 5 times negative 6 is negative 30. And we'll have the square root of 5x, because 5 times x is 5x. Inners, same thing. We're going to get negative 30 square root 5x. And then my last terms, 2 negatives make a positive 36, and it's going to be the square root of 25. When we go to simplify this, the square root of x squared is x, so our first term is going to be 25x. My middle two terms are like radicals, so I can add them together. Negative 30 plus negative 30 gives me negative 60 square root 5x. And then on the other side, 36 times the square root of 25. The square root of 25 is 5. So we're going to do 36 times 5 here, which will give me 180, so plus 180. Okay, and again, if you look at this problem, since we've simplified everything, I don't have any like terms, so I can't do any more combining. That is it.